Hey, this is Ray here, and we're going to touch a bit on VGT turbo operation. This specific turbo is off an ISL, which came out of a 2009 Gillig bus. As we can see here, we have the center section of the turbo. We have the hot side and the cold side. Your air intake, will come over here, and then that would actually spin the turbocharger, and then your boost will come out here. This is your exhaust side, your hot side. Your exhaust from your engine will come through here, spin your turbine shaft, which is actually connected to the cold side, and that's what will create your boost. These days, with emission standards and better technology, we have the variable vane turbo actuators, also known as the VGT, variable geometry turbo. And basically, an electronic actuator bolts onto the top of this and can control the size of the turbo basically just by moving the shaft back and forth. As you can see, there's soot on this side, so this is on the hot side. And as the vanes are closed, the diameter on the inside of the turbocharger is actually smaller, which would create more restriction, higher heat, and you'd have better power and better boost at lower RPMs. Whereas when you increase your RPMs, you could open up and you will, in theory, have a larger turbocharger. All of these vanes around here actually go inside of the exhaust housing. The reason why this one was changed out is a lot of carbon gets built up in the vanes and in the slots, and the shaft starts to move pretty rough, and the actuator motor on top can detect that. So that's why this one is being changed here. These turbochargers, because of the engineering involved, we have oil and coolant that go into these turbochargers to help lubricate and cool them. There is no wastegate or anything like that because this is an electronically controlled engine. So you're basing boost on RPM and limiting your fuel. Other than that, that's pretty much it as far as the VGT turbo is concerned. I would suggest that you can get, for the ISL, you can get just the turbocharger separate from the actuator. Make sure when you do install, you do have to have the turbocharger shaft, the sector shaft, timed to the actuator, or else you're going to be chewing teeth off of this or the electronic actuator. But basically low RPM, you can choke this turbocharger down. Higher resistance, equals more heat. More heat, you get more boost at lower RPM. So you're not really, you actually have a multi-function, multi-size turbocharger here. And this would be your turbocharger speed sensor. These ones spin, I believe, upwards of 50,000 RPM. And that's about it. As you can see, the cold side is a pretty standard cold side for most turbochargers. You do have a sealing ring in here for carbon. The actuator itself that does bolt onto here was reused, so you don't see it here. But there's also coolant that goes into the actuator to cool the actuator down, the motor, because it's constantly going back and forth. And besides from the power increase you get from a VGT turbo, you also get better emissions because if you get more boost at lower RPM, you can actually cut out on some of the emissions that you're having, where you would have turbo lag on an older, like an L10 or even the M11s, where you wouldn't see that with these newer ISLs. If you have any questions, feel free to post. Thanks.